Hello everyone. In this video, we're going to talk about stretches, compressions, and reflections of our parent functions. We're going to start with reflections. So we have here negative f of x is a reflection over the x-axis. Okay, so notice that the negative sign is on the outside of our function here. So it's on the outside. And as you remember from our previous video, when something is on the outside, it is affecting our y values. So this is going to negate our y values of the critical values or the key points of our function. Now, why does this go over the y-axis? Well, we're going to find that out as soon as we do the example here. Or excuse me, the x-axis. So the first thing we need to do is we need to identify our parent function. That's easy to tell that it is a x squared function. So it should look something like this. Okay, so then we need to identify our key points. So our key points are 0, 0 for this. We have 1, 1 squared is 1. And then 2 squared is 4. We also want to know what's happening on the other side of 0, 0. So negative 1 squared is also 1. And negative 2 squared is also 4. So now we need to identify our transformations. Well, in this case, I only see one reflection. Okay, so this is on the outside. So this is, I am going to negate, I'm just going to put neg there, negate our y's. I should put neg y's. Okay, so that's all we're going to do. So this, our x values are all going to stay the same. All we're doing is adjusting our y. So this is going to be 0 and then comma 0 still. 1 stays, but then negate the positive one, we get negative 1. 2 stays, this goes to negative 4. The negative 1 stays, this goes to negative 1. And the negative 2 stays, and that goes to negative 4. Now all we got to do is just plot this on our graph and graph it. So our 0, 0 stays, that's our vertex. We have 1, negative 1, that's there. 2, negative 4, that's there. And then if you recall, a parabola here is a mirror of itself, so I can just go ahead and plot these guys, which correspond to the other 2 points on our graph. Okay, so now we just graph it. Remember, it's going to be arched, or not arched, it's going to be curvy, just like so. Add our arrows in. And now you can see that it is indeed a reflection over the x-axis. So if we folded our original function, which looked like this, if we folded that over the x-axis here, it lands right on this. So it is a reflection over the x-axis. All right, let's move on to some compressions and stretches. This happens when you have a constant out in front multiplying the function. So again, this constant is on the outside. So this is only affecting, we are multiplying our y values. Okay, and there's two different ways that we can do this. So if c, the constant, is greater than 1, this results in a stretch, and you'll see why that's called that in a second. If c, that says between 0 and 1, aka a fraction, this results in a compression. Okay, and you'll also find out why that is when we do this. So originally here, what I have on this example here is we're going to graph all 3 of these. I'm going to start with the parent function. For this one, the parent function is our absolute value function. So I'm just going to write down the key points for this. It's 0, 0. We have 1, 1, 2, 2, negative 1, 1, and negative 2, 2. All right, so I'm just going to go over here and graph this guy really quickly. Here we go. So we got 0, 0 here, 1, 1, 2, 2. Just like the parabola, it is a mirror of itself, so I can go like that. And now I can graph this. You should use a straight edge for yours. Okay, so now we need to worry about this g of x. So what happens if we multiply by a constant that is bigger than 1? Well, that should result in a vertical stretch. And let's see what happens if it does. So all we're going to do is just multiply all the y values, all these guys right here, by 2. So we're going to keep all the x's and just multiply all of the y values by 2. Negative 1 goes to 2, negative 2, and 4. And now we're just going to graph this guy. See what happens. So we got 0, 0 again. They share the same vertex. Now I have 1, 2, 2, 4. And it's a mirror of itself. So I can go right there and right there. And now we graph it, and we see that it has indeed stretched itself. It's as if somebody took these two black ends and pulled it up vertically and stretched it up vertically, kind of like a slinky. All right, last thing that we need to do is we need to worry about this h of x. What happens if we multiply by 1/2? Well, the same thing. We just multiply all of our values by 1/2. 0 still goes to 0. This is 1. 1 actually goes to a half. And then we have 2 comma 2 over there. 2 times a half is just 1. So we have negative 1 going to 1/2. And now we have negative 2 going to 1. Let's see what happens here. So we have 1 comma a half, which is about right there. And it's a mirror, so it goes over there. We have 2 comma 1, 2 comma 1, and the same vertex at 0, 0. So this guy is going to go out this way. And notice how it flattened out. So again, it's as if somebody compressed a slinky, compressed it and shoved it down. What happens when a slinky gets pressed down or a spring gets pressed down? It gets fatter. Okay? So that is your compressions and stretches and also reflections. I hope this video really helped you out and helped you fill in some holes that you had previously. As always, stay safe and healthy in this time, and I will see you on the next video. Take care, guys. Bye.